back. We're in section 6.1 talking about polygons, and we talked about how to classify them by the number of sides, whether they're regular or irregular, concave or convex. Now we're ready to jump into our first theorem of the section, which is the polygon angle sum theorem. This is going to be an electronic notebook edition, and it's easy enough to type out. There's no figure that you need to see. So let me kind of take you through the notes here on this page, and then we'll do a couple of practices. First of all, this theorem applies to convex polygons, not concave. So I did want to make sure that I pointed that out. What we're doing to use this angle sum theorem is we're trying to figure out in a particular convex polygon how many triangles could you form coming from one vertex, not multiple vertices, just one. So if you look here at the triangle, there is no diagonal. It forms exactly one triangle. Okay, you have three sides, you have a triangle, has three sides, you're going to have exactly one triangle formed from those three sides. Okay, now quadrilateral, here we are here in the figure. Four sides. If we draw a diagonal from one point to another across from it, that forms two triangles. So four sides forms two triangles. Okay, let's do a pentagon. Okay, now pentagon has more choices. We can cross over there, we can cross over here. From that same vertex, we just formed three triangles. So five sides forms three triangles. And let's do the last one here, the hexagon. We have even more choices. We can go from here to here, here to here, and here to here, forming four different triangles. So six sides gives us four triangles. So there's a pattern here where we've got three sides, one triangle, four sides, two triangles, five sides, three triangles, six sides, four triangles, and so on. Now, if you don't know how many sides there are, or if we're just talking in generalities, as in using our algebra background, using variables, if I have a polygon with n number of sides, then I'm going to form n minus 2 number of triangles, because that's what the pattern is. However many sides I have, if I take away 2, that's how many triangles are forming. That's the pattern. 3 minus 2 is 1, 4 minus 2 is 2, 5 minus 2 is 3, 6 minus 2 is 4. Okay? So that's what's going on here. That's the patterning we're seeing from this example. Now this can form a theorem because we see a pattern. That means if there's one triangle, that's 180 degrees. And so 180 degrees times 1 is 180 degrees. If two triangles are formed inside that convex quadrilateral, then 2 times 180, that means there's 360 total degrees inside a quadrilateral, convex quadrilateral. If you formed three triangles, then 3 times 180 is 540. So that means pentagons have a total of 540 degrees formed by all of their angles. So that's the pattern, is what's going to happen, and that's what this theorem is about. The polygon angle sum theorem says if you have a convex polygon, if you want to know how many degrees, how many total degrees there are of all the interior angles, all together, the sum of all those interior angles, this is how you calculate it right here. You take the number of sides and subtract 2. That gives you the number of triangles inside the polygon. Multiply that times 180 because each of those triangles are 180 degrees, and you'll have the total number of degrees for that entire interior angles of that polygon. Okay, so I hope I made some sense there. So let's flip the page. So now let's apply it. We're going to, in letter A, find the sum of the interior angle measures of the convex octagon. Okay, so it's important that we know it's convex, and then because we can apply our theorem, and then it's an octagon that has 8 sides, take away 2, that means there are 6 triangles in there. 6 triangles at 180 degrees each. And if you multiply that, you're going to end up with 1,080 total degrees on the inside of that octagon. So all 8 of those angles on the inside add up to be 1,080 degrees, okay? So if it was a regular polygon, regular octagon, then we would actually be able to figure out what each of those angle measures were individually, because we could just divide it into 8 different equal parts. But I don't know if it's a regular octagon or not. I have no idea, it didn't say it. So, but I can tell you that if I added up all those interior angles of an octagon, they'll add up to be 1,080. Okay? Now letter B, we're going to do 2 things. We're going to first find the sum of the interior angle measures of a regular nonagon. Now remember, nonagon, non is 9, okay? Then they're asking us to find the measure of just one of them. I can only do that if it's a regular nonagon, and it is. And a regular nonagon just means, hey, all the angles are equal. So if I find the sum, then I should be able to find just one and divide that out. All right, so let's start with the first part. Find the sum of the interior angle measures. Okay, well, nonagon is 9 sides minus 2. That's going to give me 7 triangles inside the nonagon, each at 180 degrees. And so that's going to give me a grand total of 1,260 degrees. Okay? That's how many total degrees is inside, formed by those interior angles. Okay? Now, because it's a regular, boy, this is important. I can do the second step because it's a regular nonagon. Then I'm going to take my 1,260 and I'm going to divide it by the number of interior angles I have. I have a nonagon, and a nonagon has 9 angles. So I'm going to divide 1,260 into 9 equal pieces, and each of those angles are 140 degrees. That's what they're asking me to find. Okay, so that was a 2-parter. Let's look at letter C. Oh, we get to do some algebra, your favorite. Find the measure of each interior angle of the quadrilateral PQRS. Well, a quadrilateral has 4 sides. Take away 2, that's going to form 2 triangles inside at 180 degrees each, so for a total of 360 degrees. Now, if you have that memorized now, memorize it. That's okay. You don't have to use the formula if you've got it memorized. Okay? You should have a triangle memorized. A triangle is going to have 180 degrees, and all quadrilaterals are going to have 360 degree total of all their angles. So if you want to memorize some of these numbers, go right ahead. Now, we know the interior angles are, we have 2 of them at C degrees and 2 of them at 3C degrees. And we know that all 4 of those angles all together equal 360 degrees. So this becomes an algebra problem. We need to add up all our C's. I've got 1, 2, 3, 4, 5, 6, 7, 8. I've got 8 C's that equal 360, and then divide each side by 8. So I know that C equals 45 degrees, or 45. So that tells me that angle P and angle R, which are both C degrees, are equal to 45 degrees. Okay? And then angle S and angle Q are going to be 3 times that, which is, I think, 135. That's 135 degrees. Okay, so that's a little bit of algebra there. Hopefully you thought that was pretty fun. So I'm going to leave the check it outs for you, 1 each. You're going to find the sum of the interior angle measures of a convex 15gon, and then find the measure of each interior angle of a regular decagon. So do your best, see what you can do with that, and if you have any questions, bring them to class.